Mars. I'm sure we've all heard about Elon Musk's crazy plans to shoot lasers at the planet, or NASA's trips to Mars planned in the 2030s. Everyone wants to colonize this planet, and it's clear why. Mars gives us a never-before-seen opportunity for scientific development and to answer the universe's biggest questions, like how we are here and if there's anyone else out there like us. I became one of the many people who are obsessed with Mars and want to do as much as we can to actually make it a reality, actually get there and be able to answer all of these questions. So I was doing some research, and let me tell you what I found out. On Mars, 0.5 to 1% of the surface is made of salts called perchlorates, and these salts are really detrimental to organisms. See, these perchlorates, when they're hit by UV radiation, turn into really harmful molecules that love to take electrons from nearby atoms. This is a really big problem because instead of plants looking nice and healthy like this, they end up looking more like this. And if we then ingest these plants or just expose to perchlorates for too long, we can end up with thyroid dysfunction, which can lead to constipation and fatigue, cognitive decline, and a risk of heart disease. Humanity has not been making technological inventions and pushing ourselves for this long just for perchlorates to stop us from finally getting there. Which is why I'm working on a project called Spearlinks, where we want to use gene editing to detoxify Mars. Now, to explain the biology simply, we found a bacteria, and if we take two enzymes, and together, these two enzymes can actually reduce these perchlorates into completely harmless ions that also release oxygen into the atmosphere. The bacteria we found was Bacillus subtilis, and it can survive the temperature and pressure on Mars. But UV radiation was still a really big issue because it could cause double-strand breaks in the DNA. That's why we want to use CRISPR-Cas9 to genetically modify the bacteria so it can actually stay resilient in these harsh environments. And so what we can do is actually tweak those genes to basically give the plants superpowers so they can become more resilient and actually withstand the harsh temperatures. Then if we take this, put it in a substance of water, and put it in drones to spray across a designated and secured area, or simply do it in a bioreactor inside a habitat, we can solve this pesky perchlorates problem.